Hi everyone, in this video I'm going to teach you how to convert units using dimensional analysis. Dimensional analysis is just a way of how we convert units. If you're in chemistry, this is a tool that you'll use in your later science classes, physics, anything AP. It's pretty common, a pretty commonly used method in science. So let's get going. In science, we measure our units in metric. That's used universally, and it's really easier than the US system. We measure mass in grams, volume in liters, length in meters. This table, you might want to pause the video and take a screenshot or write it down. This is our metric conversions. What's nice about the metric system and why it's used, probably more than the US system, is all the conversions are the same. Like, what's less than a mile? I don't even know. A foot, inches, it's all confusing. Metric, it's all the same thing. And it's all based off of 10. So you have your base units, meter, liter, gram. What's smaller than a meter, a liter, or a gram is to the right. Decis, centis, millis, and it can keep going. These are smaller than a base unit. So let's look at centi. 100 centis equals 1 base unit. So say we're talking about meters. This means that 1 meter equals 100 centimeters. So they're pretty small. They're a hundredth of a meter. This way, going left, they are larger than the base unit. So if we looked at kilo, which is a commonly used one, 1 kilo is 1,000 base units. So 1 kilometer equals 1,000 meters. Let's say we were talking about volume, which is measured in liters. Because metric, it's all the same. 1 meter is 100 centimeters. 1 liter equals 100 centiliters. Now, centiliter isn't commonly used, but it could be used. And then vice versa on the other side. 1 kilometer is 1,000 meters. 1 kiloliter equals 1,000 liters. So it's all the same thing, just different units, which is nice. Now in science, our units and our numbers, they go together. So we use measured numbers. It's based off of a measurement made somewhere, and measured numbers have numerals. So your numbers, which some of those numbers are significant and some are just placeholders, and they have units. The unit is a part of the number, because let's say you asked me what temperature something was at, and I said it's at 100. Well, 100 Fahrenheit and 100 Celsius are totally different temperatures. 100 Fahrenheit is, a hot summer day. 100 Celsius is water boiling. So very different temperatures. Okay, we're going to go into converting units. So this is something you'll use in chemistry all year long. It never goes away. You're always going to be converting. And the steps to how you convert are right here. So identify the unit you're starting with. You want to figure out what you're ending with. Identify your equivalency. That is going to help you convert it. You do your math. You answer in correct significant figures. I don't really think reading these steps helps you understand how to do it, so we're just going to get started on some practice problems. So the first one, convert 25.4 milliliters to liters. So this is our number, and we want to change it to liters. I always like to stop and think, okay, I'm going from milliliters to liters. Liters are larger than milliliters, so my number should get smaller because this is big and milliliters is really small. So if we get a number that's bigger, we did our conversion wrong, if that makes any sense. Now, let's stop and think about how do we go from milliliters to liters. Well, hopefully you wrote down that chart and you know that 1 liter equals 1,000 milliliters. Now, in your head, you might be able to, okay, boom, I know what the answer is. That's wonderful, but I'm teaching you the process of how to set up converting units because your problems are not going to be like this all year. So how I start these off and how you need to start these off. We start with the number that was given, 25.4 milliliters. And I'm going to write that down. And you have to write down the unit with it. And then we're going to set up a little multiplication with a fraction. And we're going to use our conversion in this. Now, I told you the unit is a part of the number. I don't want my milliliter unit. I want the unit to be liters, not milliliters. And so, looking at my conversion, because I have milliliters on top right here, I'm going to put 1,000 milliliters at the bottom. And then on the other side, I'm going to write what it equals, which is 1 liter. Now, looking at my units, I've got milliliters here and milliliters down here. They cancel each other out. Boom. It's like they're gone, which is what I wanted, because I don't want the milliliter unit. I want the unit to be liter. And looking at it, what's left is liters. Now, for some people, you might want to write this over 1. It doesn't change anything, but that might help you see that they cancel out a little bit easier. So now I've canceled out my milliliter unit. I have the unit liter, which is what I want, so we can solve for this. We just need to do the math. And to do the math, you multiply everything across the top. So 25.4 times 1. And you divide it by everything at the bottom. So underneath, which is 1,000. When I go type that in my calculator, I get 0.0254 liters. Now, checking for significant figures, because sorry, that applies. 25.4 has 3 sig figs. This conversion right here, 1 liter to 1,000 milliliters, that is an exact conversion, so that has like unlimited significant figures. And so you always answer, okay, which one has the least amount, unlimited or 3? 3 is definitely smaller, and so our answer should have 3 significant figures, and looking at it, it does. We're going to work a few more of these problems. Next one, convert 23.9 kilometers to meters. So I'm starting with kilometers, and I want to go to meters. Looking at my metric chart, the conversion between those, 1 kilometer equals 1,000 meters. So I'm going to something smaller. I'm going from big to small, which means my number should get larger, because there's a lot of meters in 1 kilometer, and I've got 20 kilometers, well, 23. Okay, so I've written out my conversion. Now let's set up our dimensional analysis. 23.9 kilometers times, if you want to write this over 1, you can. And so where do we put each unit? I want the meter unit, so I need to get rid of kilometers. I've got kilometers at the top right here, so I'm going to put 1 kilometer at the bottom. And then on the other side, I have to write what 1 kilometer equals, which is 1,000 meters. Now, kilometer, kilometer, those units cancel. I'm left with the unit meters, which is what I wanted. And so we're good. We can solve this problem. And again, we multiply across the top, so 23.9 times 1,000 over 1. And that equals 23,900 meters. And then check significant figures. 23.9 has 3 sig figs, so my answer should have 3 sig figs, and it does. Okay, next one. This one's not as simple. Convert 22.1 centigrams to kilograms. Centigram is not super commonly used, but it could be used. And I want to change that to kilograms. So first, looking at our chart, there's not a conversion from centigram to kilogram, but there is 100 centigrams equals 1 gram. And then for kilogram, I know 1,000 grams equals 1 kilogram. So this time I'm going to have to do 2 steps in my dimensional analysis, not just one, to go from centigram to kilogram. But we start off with our given, 22.1 centigrams. And if you want to write that over 1, you can. So first up, we need to get rid of this centigram unit. So we will use this conversion first. Centigram is at the top of the first step, so I need to put 100 centigrams at the bottom of right here. And I write what it equals on the other side, 1 gram. Now, that has canceled out my centigram unit, which is what I wanted. And I'm left with grams. Grams is not my final answer, so I'm just going to make another little multiplication and a fraction. And I'm going to use this conversion this time. Now, I've got gram here, so I'm going to write 1,000 grams at the bottom. That way the gram unit cancels, because I don't want grams, I want kilograms. And on the other side, I write that 1,000 grams, that equals 1 kilogram. And so let's check. We canceled out centigrams, we canceled out grams, and we're left with kilogram, which is what we wanted to solve for. Now, to solve this problem, you multiply across the top 22.1 times 1 times 1. You divide it by what's at the bottom, 100 times 1,000. If you go and you type in your calculator exactly like this, it's not going to give you the right answer because of order of operations. Really what you want to do is you want to multiply everything across the top together. And then you want to multiply everything across the bottom together. And then you divide. But PEMDAS, if you remember that, won't type it in the calculator correct. And so 22.1 times 1 times 1, that is 22.1. If you go type in your calculator 100 times 1,000, that is 100,000. And so this is really what we want to type in our calculator, 22.1 divided by 100,000. And when I do that, I'm going to write it over here because I ran out of room. It is 0.000221 kilograms. And that answer makes sense because if you only have 22 centigrams, you don't have a lot at all. That's a very small amount. And changing it to kilograms, a kilogram's a really big unit. So it should be a very small number. Okay. Next one. How many seconds are in 14 days? And this is the last example we're going to do. Ooh, okay. So 14 days, 2 seconds. Let's just start off with 14 days. Let's think, if we want to go to seconds, what do I know about a day? You know, one day has 24 hours. So since days are up here, I'm going to write 1 day at the bottom. That gets rid of my day unit. 24 hours. Next. And day is gone. I've got hours. I want it to be in seconds. I do not know how many seconds are in an hour. Maybe you do. Congratulations if you do. But I do know that 1 hour has 60 minutes. So now my hour unit cancels. Hour, hour. And then I do know that 1 minute has 60 seconds. Boom. Minute, minute. So as you work through these problems, every time you write a new conversion, I would go through, and especially while you're getting used to how you're doing this, cancel out your units as you solve. So days canceled, hours canceled, minutes canceled, I'm left with seconds. And when I type this bad boy in, 14 days have 1,209,600 seconds. And with significant figures, this is not correct because 14 days is 2 sig figs. So I'm going to make that 1,200,000 for my final answer. I hope this video was helpful in how to solve for dimensional analysis. If you go search for other videos on YouTube, you can find so many tutorials for how to do this. Good luck!